Welcome to example 23. We have 5 resistors shown in here connected to a 12-volt battery. And we're asked to find if we were to put a voltmeter across the 5 ohm resistor, what would it read? Now, there's a lot of resistors in here, and there's probably various methods to solve. But try to think of the fastest way of solving this problem. Let's label this point here A and label that point B. And you see that if you were to label this point C or D, we realize the voltage across A to B is 12 volts, and the voltage from C to D is also 12 volts, because they're all connected in parallel to the 12 volt battery. So this branch and this branch have the same voltage. And you may realize that you really don't need the upper branch at all. You really only have to concentrate on the lower branch. You see that the voltage from A to B is 12 volts, because that's connected to the battery. Now, the resistance from A to B we can calculate because we have a 3 ohm resistor in series with a 5 ohm resistor. So that's 3 ohms plus 5 ohms, which gives you an 8 ohm resistor. So if you were to replace this with one resistor, it would be 8 ohms. So you have the voltage of 12 and 8. That means that you can find the current through this branch. You can find the current through here. That current through A to B is going to be equal to that voltage from A to B divided by the resistance of A to B. So that's 12 volts divided by 8 ohms. That gives you a current of 1.5 amps. Now that you know the current that goes through here, then you can find the voltage across this by using Ohm's law once again. So the voltage through the 5 ohm resistor, we'll call that V5, equals the current that goes through that resistor. You can call it I5, you realize, and then multiply by the resistance of that. But hopefully you see that current through here is the same as the current through that entire branch. That's 1.5 amps multiplied by a resistance of 5 ohms, and this gives you an answer of 7.5 volts. And that's it for example 23.